Okay, here's a good limiting reactant question. How many grams of nitrogen oxide are produced if 4 moles of ammonia are burned and 20 moles of oxygen? Okay, and so here I've got the chemical reaction there. So 4 moles of ammonia. So I'd need, let's see here. I have to balance this. So I think this would be 4 over there, right, to get 4 N's. And then I have 12 hydrogens here, so I need a 6 here. And then let's count up oxygen. 6 plus another 4, that's 10. So I need to have 5 there. Good. Okay, so I have 4 moles of ammonia and 20 moles of oxygen. And they want to know what the mass of nitrogen oxide is. So it's a limiting reactant question. So I need to determine which one is the limiting reactant. So when I do that, I always start with the first one. And they gave me 4 moles, so I don't need to convert to moles because I know 4 moles already. Times by, I want to figure out how many moles of oxygen I would need if I burned all 4 moles of ammonia. So to do that, I would multiply it by the 5 of oxygen divided by the 4 of ammonia. So this is oxygen and ammonia. Okay, so that would be 5 moles of oxygen required to burn all the ammonia. Okay, but I look right here, I have 20 moles of oxygen. So I need 5 moles to burn up all this ammonia, but I've got 20. So oxygen I have way too much of. This is excess. So my limiting reactant will be this one here, the ammonia. Okay, so I'm starting at moles here. I didn't have to convert from grams to moles, so I didn't have to do that step. I just have to start at moles, do a mole ratio to get over to nitrogen oxide. So this side is NH3, and then I'm going to have to go up to a solid. Good. So I have moles, so I need to do mole ratio. So I start with 4 moles of ammonia, and I'm going to nitrogen oxide, which is 4 moles of NO over 4 moles of ammonia. That's funny that they gave us 4 moles to start with. I maybe should write it, the first one, like that. So I have my sig figs in. Okay, of course this is going to be 4 moles, or 4.00 moles of nitrogen oxide. And the last step will be to convert the moles into mass of nitrogen oxide. So nitrogen is 14.01 and oxygen is 16. So that'll be 30.01. So to go from moles of NO to mass of NO will be moles is equal to mass over molar mass, but I'm solving for little m. So little m will be equal to moles times molar mass. The moles are right here, 4.00 moles times by the molar mass, 30.01 grams per mole. So when I times those, I get 120.04 grams. When I look at sig figs, I look like I have 3 sig figs everywhere, so I can only give 3 sig figs. 120 grams. That'll be how much NO is produced.